story before we get started and let you understand why it is that I'm so passionate and so committed to this story that we're going to unfold for you today. It takes some courage to understand the story because we have to open ourselves to grief. So the question is, do we have the courage to hold the grief that comes with the end of a story? It's my belief that this is the end of a story. I came to this knowledge about global warming on an emotional level about 2 years ago. I was coming back from England and I was flying to Denver, and it was a direct flight, and our flight for some reason was directed on a more northerly pass than it had been planned, and as it turned out, we flew directly over Greenland. Now, I had flown over Greenland several times in the 60s and the 70s as a child because I had grown up overseas. And I knew about Greenland. I knew it was a massive, white expanse, unbroken, clean, just this unending sheet of ice. So when I flew over Greenland in early September of 2012, I was not prepared for what I saw. The first thing that I saw were thousands and thousands of icebergs. As we approached the island from England towards, flying west, there were thousands upon thousands upon thousands of icebergs in the water. At first I thought the water was very choppy and very rough, but then I soon realized that these were actually icebergs and they had been discharged from the island itself. I didn't see the island yet. Then we got closer and I saw the island, and it was a towering mass of gray stone mountains rising up sharply. And the ice cover was very, very thin and very dirty and runny, and the whole thing, and keep in mind too, this was the southern half of the island, but it looked like a melted ice cream cone sundae, and it was very, very sad. A lot of very dark, very condensed ice. And I had a visceral awakening at that moment because the comparison of going over Greenland 30 and 40 years earlier and now was stark, was shocking. And I realized that global warming is very, very much underway. So this is, my effort to tell you about this situation today.
Well, good evening, everyone, and welcome to Environmental Coffee House. It's really good to be here with all of you. We have a busy show, and welcome Jennifer and Jim. And Jennifer, that was a tribute to your 2015 work in the beginning of that. I hope
2014, that
14.
was the methane monster from
Yeah,
2014, this
I
time
hope
of
you
year,
liked it.
7 years ago. I loved it. I was surprised. I had no idea that you were gonna do that. That was my old methane monster,
Well,
the
no, I'm a
opening of it.
surprise a minute. But we certainly have a busy evening. I'm going to give it to Jennifer to go through the articles, but it'll be more of a discussion. But they're based on the articles because there's so much out there now, all of a sudden, and of course. When this happens, guys, these new research articles come out. It's a big thing. Everybody talks about it. And like in the Twitter sphere, there's, arguing. It's alarmist. It's stupid. It's bullshit. Or then all it's, oh, we just have to get off fossil fuels. But then it dies down. It'll go away.
Mhm.
And everyone will
Yeah.
forget. But we won't let you forget because we've been talking about this for how long? I was looking at old videos of myself today, Jennifer, from way
For
back
you?
before. Yeah, talking about this. I didn't even know what the hell an AMOC
God.
was. It was Kevin Hester who taught me what that was. So, welcome everybody, and it's really great to see all of you. Oh, thank you, Rich Diana. I got a haircut. That's a whole nother story. Jennifer, that's a story I'll tell on my own. Has to do with my
Yeah.
mother. Okay, Jennifer. Jim, it's great to see
Alright.
you.
Good
All
to see you
right.
guys too.
Great to see you, Jim. Great to see you, Sandy. It's
All right,
really good
sweetheart.
to be here with both of you today. It is such a significant time, and we're going to try and sum it up. It's difficult to sum it up in an hour, but
Yeah,
here we go,
I'd
guys.
say.
So, we're going to start off with an article from the Smithsonian about the permafrost. Permafrost thaw in Siberia creates a ticking methane bomb of greenhouse gases, scientists warn. And this is mostly about the thermogenic methane, which we will get into and explain. We have a little article that we're just going to point to from the Climate Crisis Advisory Group, and there are a couple of graphs in there that we're going to go through. It's just out. It's entitled Extreme Weather Events in the Arctic and Beyond, a Global State of Emergency. This is an excellent PDF that Sandy's going to put into the show notes. It's actually 18 pages, very comprehensive, from the Climate Crisis Advisory Group. Then we're going to go into an article from PNAS, the Proceedings of the National Academy of Sciences, and methane release from carbonate rock formations. This is what we're going to be focusing
Yeah.
on tonight in the Siberian permafrost area during and after the 2020 heat wave. So, what happened after the heat wave as a consequence of Siberia getting so very, very, very hot?
Yes.
New discoveries. We're going to look at some pictures that Sandy will show, really more kind of like maps and graphics that are very interesting about the subcrops and outcrops of the Paleozoic carbonate, that's limestone. Then we're going to turn our eyes to the AMOC because
Yeah.
everything is connected and everything is related. And this is Jim's specialty area. The AMOC is running amok and may cause havoc. So Sandy will give us a little intro, and
I
then
found that little one.
we probably won't read this one, but it's a very good article. We'll see where we go. This is from livescience.com, also about the Gulf Stream. Gulf Stream could be veering towards irreversible collapse, a new analysis warns. The shutdown would have catastrophic effects across the globe, and then we will finish off, we will probably just allude to and not read observation based early warning signals for a collapse of the Atlantic Meridional overturning circulation. So, just a lot of good feelings and,
Well, good and truthful,
not.
and I can't wait to hear both of you in your respective areas. I feel really blessed and lucky in some spiritual way that we are together. And Jim,
It's significant.
yeah,
I
it
feel that
is.
way too, Sandy.
It
It
is.
is very
I
significant.
pulled Jim right out of the air, and I pulled
You
you. I
did.
didn't pull you out of the air. No, Stephen Mason introduced me to Jim. Stephen Mason, a couple of years ago.
Right.
Yeah. All right. Well, everybody's joined, and we have a pretty good audience, and it's a lot of
Yeah.
gratitude out here tonight. So why don't we take it
That's
away
great.
with the first one? And I'm going to pull up
Right.
the. Here we go. Let's pull up that first one, and that is the Smithsonian one. Take it away,
Yes, the
Jen.
Smithsonian permafrost thaw in Siberia creates a ticking methane bomb of greenhouse gases, scientists warn. Subtitled in 2020, temperatures in the region rose nearly 11 degrees Fahrenheit above normal,
Yeah.
causing the limestone to release ancient methane deposits. So we're not even going to be talking about biological methane that comes out of, thawing or
No, this
thawing
is a
from permafrost.
different ball
Yeah.
game.
This one isn't too long actually, so I am going to go ahead and go through it. In recent years, climate scientists have warned thawing permafrost in Siberia may be a methane time bomb, detonating slowly. Now, a peer-reviewed study using satellite imagery and a review by an international organization are warning that warming temperatures in the far northern reaches of Russia are releasing massive measures of methane, a potent greenhouse gas with considerably more warming power than carbon dioxide. It's not good news if it's right. Well, it is right, isn't it? Robert Max Holmes, a senior scientist at Woodwell Climate Research Center. That used to be called Woods Hole.
Yeah,
They
Woods Hole.
changed it to Woodwell. So Woodwell Climate Research Center, who was not involved in either report. Nobody wants to see more potentially nasty feedbacks, and this is potentially one. Published in the Proceedings of the National Academy of Science Journal, the study of satellite photos of previously unexplored site in Siberia detected a large amount of methane being released from exposed limestone. A heat wave in 2020 was responsible for the emissions along the two large strips of rock formations in the Yeniski-Katanga Basin, located several hundred miles north of the Arctic Circle. Lead author Nicholas Freudsheim, a geoscientist at the University of Bonn in Germany, is concerned about his study's findings. No shit, right? Interpreting this data correctly may make the difference between catastrophic and catastrophe and apocalypse as the climate crisis worsens. In 2020, temperatures in the basin rose nearly 11 degrees above normal, causing the limestone to release ancient methane deposits that had been trapped inside. The data caught Freudsheim and other researchers by surprise, always by surprise, who anticipated finding gas in other locations. But, we knew about this. This is not new. It's just being measured. You can see it now because of all the heat, but we knew about this. Another report echoes these anxieties, published by the Climate Crisis Advisory Group, which is also known as CCAG. It calls for a global state of emergency as temperatures continue to climb in Siberia and other Arctic regions. Permafrost covers 65% of Russian lands, but it's not. They say it's melting fast. It's thawing. Technically, permafrost thaws, not melts, because it's not ice. Scientists have been shocked that the warm weather conducive to permafrost thawing is occurring roughly 70 years ahead of model projections. What a shock, right? CCAG warning states. Of course, we knew it. Everything is faster than expected and exponentially faster than expected. So does that make it better that it's happening now rather than in 70 years? you know?
No.
It also points out that the Arctic could lose 89% of its permafrost by 2100. Always 2100. But 89% of its permafrost, think of it, like that's a huge giant expanse. That was reported in the Moscow Times. The CCAG report cautions that warming temperatures could be pushing the Arctic towards an irreversible tipping point, causing the release of methane and other gases, as well as crumbling infrastructure in Siberia, including dams and a nuclear power plant.
That's
Go
always
team!
fun.
Just
Go
what
team.
remember what happened to Norilsk with the
Yes.
Nornickel,
All the
Sandy? Well,
mess.
guess what's going to happen to this freaking nuclear power plant that's
Yeah.
built on permafrost?
Well, there's a lot more ramifications of that, Jennifer.
Oh my
Absolutely. I know.
Oh my God. The story is simple. Climate change is happening faster than anticipated, as we all here have been saying for years and years. One consequence, the loss of ice in the polar regions, is also a driver for more rapid global heating and disastrously rapid global sea level rise. Well, the sea level rise will be kind of like the cherry on the top, because we'll be experiencing very, very bad things way before then. So that
we are.
concludes. Yeah, we are. We're seeing. I saw the most incredible article. I mean, Film Today, put out by DW after the flood. It was all about Germany
Cleaning
and
up.
the regions that got hit so hard with this abrupt climate change event that just basically wiped out all these villages and towns that were hundreds and hundreds of years old, and these people were just crushed. So it's not like the apocalypse is going to be exciting. It's going to be freaking devastating. And that's kind of what we're coming to, Sandy.
Yeah. And we're, we're not being alarmist. We're being realist. I hate the word alarmist. I hate those idiots that have to say it's alarmism. We are providing the research. If you want to wake up, wake up. If you want to sleep through it and just be, live your life with a blindfold on, go ahead. It's going to be harder for people like Antonio. They have to live through this. And I give him a lot of kudos.
Absolutely. Absolutely. So what I want to do now is dive into this article that they alluded to in the Smithsonian article. The CCAG from the Climate Crisis Advisory Group, Extreme Weather Events in the Arctic and Beyond, a Global State of Emergency. So this is a really good PDF. You can read it at your leisure. It'll be in the show notes.
Absolutely.
And what I want to do is jump down to figure 1, Sandy, if we can, and that is the amplification of temperature change in the Arctic, annual anomalies relative to 1850 to 1900 average. So what we can notice, this is a really good example of Arctic amplification. We always are saying, oh, it's heating up in the Arctic 3 to 4 times, maybe 4 times as much as the global average. What does that really mean? Well, this is what it means. It means this jagged red line that is curving up to our doom. And it really does a breakaway in about 1990. You can see that it's pretty well tracking with the global average along the whole time. And then about 1990 or almost to 2000, looks like 95 or so, it really starts to take off. And those of us who've been tracking the temperatures in the Arctic and looking at like Arctic anomaly map, we always see like it's just blazing red in the Arctic because that's the anomaly, how far off it is from what it should be. And this shows you the story of how that happened. So that's Arctic amplification on steroids. It's very, very scary.
And then there was the other one, the sea ice volume.
Yeah, the Arctic sea ice volume in September declining by 3,200 kilometers to the third power per decade. I can't even really calculate that. Well, maybe, but it's going to be roasting to the people because look at this thing. It's really the Arctic sea ice is going down. And check it out. The lowest it ever hit was in 2012.
Yes.
Coincidentally, that was the year that I flew over Greenland, that bit that Sandy played at the
Wow.
beginning, and I was just freaking shocked out of my socks as we flew over Greenland in 2012 after being at the Olympics in London. It was such an amazing time, and just flying over Greenland and seeing the whole thing melting down. And that was indicative of everything that was happening in the Arctic that year. That year, 95% of the surface area of Greenland was melting in August of 2012. And it hasn't gotten that low as far as Arctic sea ice volume since then. It's come close. But what this doesn't, well, this is volume. So
Is
I
there
guess the volume.
another
You know
graph?
what?
Because this is a pretty good.
This
If
is
I
a
may
pretty.
jump in here for a
Jump
moment,
right
Yeah,
in,
please.
please.
Jim. Jim,
Jump in,
jump
Jim.
in, Jim.
Jump in,
Not
Jim.
What
literally.
you need to, okay, that graph is showing the ice in September. Keep in mind, September is the month, it's the oceanic summer. So the ice will be at a minimum in September. They also stated it was like 3,200 cubic kilometers per decade. So that's an averaging over time. What I would like to see is the ice, a similar graph, but done in March, which would be the oceanic winter.
Interesting.
That to me would be telling, because when you're losing 3,200 cubic kilometers of ice per decade, you're losing the multi-year ice as well. And it's the multi-year ice that reflects sun energy back into space. You lose the multi-year ice, even if you form, whether it's greasy ice or frazzle ice, you're still going to get some sunlight energy penetrating through the ice and being absorbed by the ocean. So
Yeah.
the albedo is going to be reduced, whether it's open ocean or just greasy frazzle ice, even pancake ice. So overall, it's not a good situation. And as I'll discuss later on, the main reason for the loss of sea ice is not necessarily sun energy from above, but heat content from below.
Yeah.
Okay.
And
My
Sandy,
gosh.
one thing I want to say about this
Yeah.
Arctic
Thanks.
supposed sea ice volume in September,
Yeah.
I'm looking at this graphic and I can tell by looking at it, because I've looked at these graphs so many times over
Yes.
the years. This is not Arctic sea ice volume. This is Arctic sea ice area. This is misnamed. If it was Arctic sea ice volume, you would see a
Good
very different
catch.
picture. Yep.
Then you have to
And
write
this,
to these people. Let's
well,
see if
isn't
they
it
have it in.
funny? I mean, this is like the CCAG. You would think they would understand the difference between volume and sea ice area, because it's so very, very different. Volume, this graph would not look like this because the volume is continually decreasing. And today we have less Arctic sea ice volume than we had in 2012 by a great deal. And that's how I know, by looking at this, this is not volume.
Maybe you
This
should
is
be a
sea ice
reviewer.
area.
You could be
Well,
a
I
reviewer.
don't know.
You could be a reviewer.
I don't know.
Yeah.
But sea ice volume is actually more important than sea ice area, because, as Jim has mentioned,
Yeah. Volume.
when yeah, absolutely, the sea ice volume has a lot to do with the multi-year ice. There is no multi-year ice left in the Arctic, hardly at all. There used to be some, like right along the north of Greenland, kind of like a crust of ice that had kind of like packed together, and just kind of from the gyre it had sort of smacked onto the north of Greenland. We thought that would never melt, but in one month a couple of years ago, I think it was 2019, it just completely melted in the north of Greenland. So ice melts. Ice plus heat equals water. So we are heading for a blue ocean event. When? Everybody wants to know when. We don't know when, but we do know that when the Arctic sea ice goes, the Arctic Ocean is going to heat up greatly, because all the energy that is going into melting the ice will just go into heating the water. And when that happens, as there are so many methane deposits in the Arctic Ocean itself, those are going to heat up, and the permafrost is going to thaw, and then the methane deposits are going to come out, both biologic and thermogenic. So both types. But what we really want to cover tonight is the methane releases from carbonate rock formations in Siberian permafrost.
Yeah. This is the PNAS article, which of course we're not going to read,
Yes.
but we'll talk
No.
about it.
Yes. Yeah,
There
absolutely.
also was, yeah, let's see. You have
And this
the-
is
the
Nicholas.
graph.
This is Nicholas Fritzheim.
Yeah, Freudheim. Freudheim.
Yeah.
There we
Yeah,
go.
from Bonn, Germany.
Yep.
And there are certain formations, Sandy, and actually, if you could bring up that picture of the Tamer fold belt of the very northern part of Siberia, this is a little bit of land that extends. It's still land because it's not yet submerged, as most of the Arctic permafrost actually was not submerged, and it became submerged at the end of the last ice age due to sea level rise. So take a look at that belt of the subcrops and outcrops of Paleozoic carbonates. And this is this huge, giant, hundreds and hundreds of miles long limestone formation. And for the very first time, this limestone formation got really hot. Remember, the sun was just beating and beating down. And remember, it was 100 degrees in Siberia, and those people were jumping into the Arctic Ocean and doing all these crazy things, right? Well, this limestone also heated up, and there is geologic thermogenic methane stores that are ancient, and we actually don't know all the things that are under here. There could be massive methane basins that could come out, because as we know, and this is the most important thing, takeaway about methane, is that methane is very expansive. And when it gets hot and it comes out of the ice state, which is methane hydrate, into the gaseous state, it doesn't have a liquid state, it expands to the tune of something like 160 times. That's why those big methane blowholes are happening up in the Yamal Peninsula, because when the methane thaws out, it basically expands, creates a lot of pressure, and it blows the top of the permafrost off, right? Wow. Those are those methane craters that we've been studying together for years. But this is a little bit different. The source of this methane is not biological. It is not based in decomposing bacteria that are outgassing various methane bits. No, this is completely different. And it is coming out so strongly from this limestone that it has taken everybody by surprise. All these big subcrops that are kind of at the top of the little land formations, these subcrops and outcrops of Paleozoic carbonate are heating up, and they are just gassing out methane. It's absolutely stunning, Sandy and Jim.
And so I read. But these were interesting graphics for sure.
For sure. They really are.
Well, it's interesting. It's scary. It's, most people are not going to even flinch or understand what the ramifications are. Although, being that the Washington Post and the mainstream media is reporting on this, perhaps it will become something that maybe it will be more than just a passing conversation with some people, but I don't know. I tend to think not. I
don't think so. I don't know. Honestly.
Till they can't breathe.
Yeah, I don't know.
Till we can't grow our food.
Well, it is going to affect things. It's going to exacerbate the situation. It's going to make abrupt climate change much, much worse. It's going to add a lot of heat to the atmosphere. Hot air, basically stores 7% more water vapor per degree Celsius that it goes up. So say we've gone up, I mean, it's debatable how much, I don't want to get in an argument of how exactly much we've gone up because it varies, but however much we've gone up, there is a lot more water being stored in the atmosphere. And additionally, there's a lot more energy. And additionally, the jet stream is dipping way, way down and pushing way, way up because the temperature difference between the northern regions in the Arctic Circle, where it should be ice cold, and the temperate regions, this is getting warmer. And so it is not staying up here. And there's some really good graphics. If you take time to go through these papers, you'll understand it. I mean, you probably already understand it all, but it's very interesting.
Our followers are quite sophisticated,
Yes,
and they
are.
understand things like I'll just pull one up real quick, like this, like things like this, if I can show it, with everything's in the way, but the graphics are in each of these. And what does this one show?
Well, this one
is
isn't
the-
really, I mean, it's kind of interesting, but it's basically month by month in 2020
Okay.
and up through. So basically a year in the life of the methane cycle. So what you can see here is, if you see, the very first one is from 2020, May 16th. The very last one is from 2021, May 15th. So what a difference a year makes. This is the area that we're talking about.
Yeah.
In 2020, there was a giant freaking heat wave, as you can see. So this illustrates the heat wave that hit the Siberian region last year when it was 100 degrees in Siberia, and you can see it right all along. And then look at basically April. It's starting to get like all red, right? And you can see it looks a lot different. The point is, look at the difference between basically 2020 May and 2021 May. Look at the
Yeah.
difference between that, and that kind of tells the picture right
Sure.
there. I mean, this is abrupt. This is the word abrupt in abrupt climate change. That's what we're
Yes.
seeing here.
Abrupt climate pollution chaos. There we go. There we go. All right. Well, I think I'm going to meander over to this one article. Now, of course, this is just, and I'm going to, this will be to segue into Jim. This was about the AMOC, and it was where I got the title, Running Amok May Cause Havoc. Well, actually, I was using the title, and I realized I used that title in 2017. I guess it's a typical title, AMOC Running Amok. So I used it again, and these guys were just, it's a free thought blog, and they said, hooray for physics, it keeps the Atlantic Meridional overturning circulation churning. And it just goes into a little bit, which I think everybody here understands what the AMOC is. It's a product of the gigantic ocean-wide balancing act, and it starts in the tropics. And I'm not going into this. Jim is going to go into this. It's just, I pulled it up for you guys to read, and they are a little snarky. They were like, well, the polar vortex was bad, but you ain't seen nothing yet. If this critical part of ocean circulation collapses in our lifetime, then can we drag out all the climate denying Republicans and hang them? It would be more helpful to do it before, but I guess we have to wait until they complete the destruction of human civilization, and I think that one will get our honorary toilet flush. There you go. Okay. I had to do it. I had to do it. And really, I am so, I'm obsessed with the deniers, and I get so angry at them when I see them. But, okay. So now that I did my little thing here, Jim, I'm going to give it to you. We have that other article. I know you're not going to read it, but this was in Live Science because I didn't want to pull up any of the mainstream, but this was in Live Science, and this was from the Nature Climate Change article. So, Jim, take it away.
Okay, well, there's been a lot of headlines recently saying, AMOC Gulf Stream is getting ready to shut down. Now, we want to avoid hyperbole. However, having said that, researchers from Dalhousie University in Dartmouth, Nova Scotia, Halifax, Dartmouth, Twin Cities there, have been for the last 10, 20 years or so, they have been measuring a slowdown in what we owe.
Oh, tell me this is not happening. When it's Jim's turn.
You know what I was thinking, Sandy?
What?
I don't know if Jim can hear us, but that picture with
Oceanographer
all the
saw
eddies
chimney
and
in the Gin Sea at that point. Yeah, and that's the other thing. You see the diagrams, and the diagrams is not how the flow is. It's just to give people an idea.
Okay,
of
which
how things are.
which diagram, Jim? Do you want me to pull that one up?
the very
The
first
one with the blue and
in
the
Life
red
Science.
colors there. The one with the blue and the red.
All right, I will find it. This one. The thermohaline circulation?
That one there.
Okay, good. Because we lost you for a minute, Jim. I just wanted to tell you.
Yeah, that's that is a general representation. Need to keep in mind that the Gulf Stream is not a ribbon as is like represented here, but there are a lot of mesoscale eddies that pinch off. There's a lot of diverging flows from this, and yes, it does originate in the Gulf of Mexico. It speeds up from 35 cm to about 150 cm by the time it gets past Newfoundland. So it picks up speed, and that's due to the fact that Earth is a rotating body with fluids rotating on it. So there's vorticity issues as well. So where you see it says deep water formation, that's off the Labrador region. The other deep water formation that you see towards Scandinavia, that's the Gin Sea, and that's pretty much the major location for deep water formation. Well, as the water sinks there, it tends to pull the Gulf Stream along. So if AMOC is slowing down, the chimney formation, the start of the thermohaline circulation where it's going vertical, then it makes sense that the Gulf Stream would also be slowing down. And there is some data to indicate that this is happening. But the thing is, the Gulf Stream has actually been slowing for at least several centuries. It just seems to be that the rate of slowing is picking up. To say that it's going to totally collapse within 2-3 years, that's journalists taking, I guess, some artistic license, which I don't
like they do on Twitter
agree with. Now, the work of the late Wally Broker, he did a lot of work on looking at the what was colloquially called the conveyor belt. His work demonstrated that when AMOC slows down and the Gulf Stream slows down, leading to shutdown, that it occurs over about several decades, like about 30 to 40 years. So I'm going to go with what Dr. Broker has done in the past. He has demonstrated convincingly that it takes about 3-4 decades. So let's go with that. Okay. Now, if you were to look at the videos I did from 3-4 years ago, when I first started my channel, I was arguing that global warming will lead to an ice age or cooling down of the planet because it's a major heat distribution mechanism for the planet, and you're no longer transporting heat up from low latitudes to high latitude, so a cool down will take place. And indeed, as AMOC slows down and the Gulf Stream slows down, it should be expected, and it will happen, that areas like the UK and Scandinavia and that section of Europe will experience cooler conditions. And there's already some anecdotal evidence to that point. But here's the difference. That is probably going to be more regional as opposed to more global. Why do I say that? The reason is because of 200 plus zettajoules of heat energy in the oceans already, with 138 zettajoules in the upper 500 meters of the ocean. If you slow down the vertical currents, the thermohaline currents, you are not going to sequester. I'm getting bombed here.
Your cat looks like my cat. That's funny.
Oh,
So we just got video bombed. Anyway.
I wish I had a meow. I don't have
What
a
a
meow.
beauty.
Say hi.
Hi.
What a good
Aw.
pussy cat.
Anyway, so you're not going to sequester the heat to depth, as well as not sequestering. Okay, moving along. As long as sequestering CO2. Yes, free entertainment. But anyway, so you're not going to sequester the heat. That heat, yes, the ocean continued absorbing heat. The heat's going to lead to thermal expansion along with the ice melt. So sea levels will go up. But that heat that's in the ocean is going to diffuse back into the atmosphere. And because it's going to diffuse back into the atmosphere, it's going to keep the atmosphere warmer. Now, the other thing to keep in mind is, I just did a 2-part video series explaining why sea ice is melting. And yes, the heat from the atmosphere, open waters is, yes, okay, we're not going to do any kissies right now, but the heat from the atmosphere is a contributing factor.
Tell your kitty cat it's a serious topic.
She wants to be fed.
Too bad. I locked mine out. Whoops. I lost you guys.
But
Okay.
but the thing is that, you know, as I just did a 2-part video explaining why the major reason why sea ice is disappearing, and that is because of the heat content in the oceans. You have the flow through the Fram Strait. You also have flow off the Barents Sea opening, but that's more of a shallow shelf process. The flow through the Fram Strait is where you actually have North Atlantic intermediate water moving into the Arctic Ocean and getting into more of the basin regions as well. You also have flow coming in from the Bering Sea side, from the Bering Strait. So that is bringing increased heat as well as increased flow rates. Okay, Lily, enough now. Okay, be a good girl, lie down there. Okay, so you have all that heat coming in. Now, the section of the current that flows in through the Fram Strait actually splits off. Is one of those splits off from the Gulf Stream from before it gets into the Jinsey region. So the question now becomes, he's really being insistent, the question now becomes, as the Gulf Stream slows down, will this flow also slow down and thus be reduced to the Arctic Ocean? Or will the flow from because this is an intermediate depth, that will still continue in? Because intermediate waters flow at a slower rate, but they still continue. So there's going to be a lag effect. So I see this as, even though vertical sinking may slow down, the Gulf Stream may slow down, the pinch off, the North Atlantic intermediate water, I still see that flowing in through the Fram Strait, bringing heat into the Arctic Ocean. Couple that with heat from the Pacific side, that will continue to bring heat. That heat diffuses upward. It melts the ice from below. This is the major reason why the sea ice is disappearing, because you have the ocean heat content. As I said before, we have data for, when you have like Lake Agassiz, for example, that let loose and you flooded the North Atlantic with fresh water. It shut down the thermohaline flow, the Little Dryas, all these. We have the data for this that indicates when you flood the the North Atlantic with a freshwater lens, you shut everything down. Now I say you have so much heat, latent heat energy in the system that it's going to continue. It's really going to continue. So I do not see this as a global cooling, but more of a regional cooling. Now, what will be bad is, and this is don't see, no, she's on the printer now. What will be bad is that if you stratify the oceans, because the heat will stay stratified, if you stratify the ocean, eventually you're not gonna have the vertical mixing to bring nutrients into the photic zone. Productivity will eventually go to zero at some point.
Mm-hmm.
Productivity
And
goes to
Jim,
zero, and we have data that demonstrates this clearly.
what is causing the oceans to stratify? Could you elucidate that on that?
It's the heat. It's the heat content, and because remember, the thermohaline flow sequesters heat and CO2 to depth. If that is slowing down, if you're not having the downwelling, that will also slow down the heat content at depth. You might remember we did a program some time ago where we looked at the ocean heat content at like 0 to 500 meters, 500,000 meters, and so on. And you can clearly see a lot of that heat energy is in the upper 500 meters. So you're going to create basically very strong thermocline in the oceans. That's going to be a barrier to prevent nutrients from coming up into the photic zone to be mixed. And then productivity will drop off, and you'll be looking at a collapse of the entire food chain system.
Yeah.
And keep in mind, phytoplanktons provide 55 to 80% of atmospheric oxygen.
Oh, that is scary. Jim, I have a question for you regarding Europe and the temperatures in Europe, especially England, and everything that is kind of kissed by the Gulf Stream. If the Gulf Stream slows down, could England get a little bit chillier, perhaps? And then it would sort of be offset. Yeah. So basically it would get hotter overall. Everybody else is cooking, but England will stay almost the same because it's sort of an offset, right?
With the slowing down of the Gulf Stream, it is expected that the UK and Scandinavia particularly will cool down. They will see cooler temperatures, perhaps in, like, say, Scandinavia, more snow events, that sort of stuff. So that is to be expected. The difference is that in the past, when you have freshwater lenses and slow down an AMOC or shut down an AMOC, that would be enough to tip the planet into promoting the growth of ice sheets. So you have a glacial period. What I am arguing here is looking, if I may finish, what I'm arguing here is that with the difference now is we have so much latent heat energy in the oceans now that what's going to happen, the cooling down in Europe and the UK is only going to be a local thing, not translating to a global thing, because you have the rest of the oceans with all that heat energy that's going to diffuse into the atmosphere.
Right. And there's so much heat coming into this system that, I don't really see us entering an ice age as the result of this, current shutting down. Do you?
I do not. In the past, yes, we had data that indicated that. The main difference is now all the heat energy that we have put into the ocean. And here's another thing. Since 1971, that's what, 50-year period now, the oceans have absorbed 93% of all greenhouse gas emissions that humans have put into the atmosphere. 93%. So just think what the 7% that stayed in the atmosphere, what damage that 7%, what havoc that 7% is causing. Right. You still got another 93% to deal with.
And And since the oceans have absorbed that much of the heat content and consequently probably the carbon dioxide got rinsed into the ocean as well, right? Wouldn't that change the pH of the oceans? And
Oh,
that's why the clams and all those little shellfish aren't able to form their shells as well because of the carbonic acid that's getting rinsed into the ocean from the excessive carbon dioxide.
exactly. But here's the other thing. In fact, we actually are measuring what's called the lysocline, which is a sharp change in the basically the calcite content of the ocean, where below the lysocline, because of pressure and that kind of consideration, calcite stays in solution. Above it, it can precipitate. So organisms above the lysocline can precipitate calcite to make their shells. Well, the lysocline is getting shallower. So this is impacting the organism's ability to make their shells, make their homes. But yes, the CO2 is being mixed into in the water to form the carbonic acid, as you said. And when you have the thermohaline flow running, it sequesters that to depth. That's all kind of good and dandy. With the slowdown and the stratification and the reduced vertical flow, we are concentrating the CO2, carbonic acid form, and yes, it does reduce the pH, increases the acidity. But here's the other thing. As you warm up the waters, gas solubility decreases with an increase in water temperature. So at some point, the oceans will no longer be able to absorb the CO2 that humans keep pumping into the atmosphere. And as the waters continue to warm even more so, you're going to blow past what's called saturation solubility, so that the CO2 that's in solution in the ocean will outgas back into the atmosphere.
Right. So just like the Amazon has now become a carbon source rather than a carbon sink, we've been used to the ocean basically forgiving all our carbon sins and being a carbon sink. But at some point, what you're saying is that cycle will turn and the ocean will actually become a source of carbon. Am I reading you right?
You're exactly correct. And again, there's data that indicates that. I've had people argue with me. It's like, well, this graph shows CO2 levels increase after temperatures increase, so CO2 doesn't control temperature. I said, that's a secondary spike. That secondary spike is the outgassing from the ocean. We have the data that shows that.
All right.
So yes,
question.
that is a possibility that as you continue to warm up the ocean, the CO2 will outgas back out into the atmosphere, and we know what that means. And don't forget, there's about a decade lag time between whatever the CO2 level was a decade ago to the effects we now feel. So just think 10, 20 years down the line, what the effects will be from today's current CO2 level. And you're seeing more and more papers talking about CO2 equivalent level, where they bring in the methane and the nitrous oxide effects, so that they compute a CO2 equivalent. And it's basically pushing 600 parts per million.
All right. Can I
It is
ask a
very
question?
scary.
I have to ask a question. This may seem, rudimentary here. It is. But I'm going to pull this up and I want to ask a question. And we do have questions from everybody also that I have. But I'm going to pull this up because I want to ask you then. Whoops, where is it? All right, let me find it. Okay, is this clickbait? Gulf Stream collapse will be ultra catastrophic. What next? It's looking truly lousy. From this digital journal. Is it clickbait?
Well, the title is kind of.
Yeah, that's clickbait.
The ramifications of the Gulf Stream collapsing or stopping is, in the past, would be no more heat mechanism for the planet, but as just described, all the heat energy in the ocean, the heat is going to still diffuse into the atmosphere. The main concern, in my view, is what happens to ocean productivity, considering that, how many billions of people get their protein from sources from the ocean. If you drop the productivity, That's problematic, obviously, because then you're going to have
Right.
mass starvation. But also, as I said before, phytoplanktons provide a lot of the atmospheric oxygen, and if they start dying off, so does the atmospheric
Okay.
oxygen levels will decrease. And by the way, did I mention some recent studies have measured a decrease in atmospheric oxygen
Yes.
to under
Well,
20%?
oh yes, yes. Well, it's going down. It's cyclic. It's kind of like the Keeling curve in reverse, right? And it is also exponentially going down. And oxygen has a cycle, and it goes, it kind of goes just like the Keeling curve, but every year is a little bit lower. So you said now that you're seeing the oxygen is less than 20% in some studies. I believe that.
Yeah, yeah. That's what I'm seeing, which is of concern, obviously. No, it's one of those things. It's because the ocean is so vast, it's not gonna suddenly tank to it's 8%. It's not gonna happen like
Right.
tomorrow.
Slowly.
But the overall trend, you have to again look at the overall trend. You have to take the cycles into account when doing the analyses, and the trend is of a decrease in the oxygen levels.
Well, Jim,
Right.
let's take some questions. We are chugging along. We are at an hour, and I think maybe this one from Tina. Maybe Jim can comment on the Heinrich Oschler events every 6,000 years or so that cooled the northern hemisphere. Of course, I don't have a clue what that is. So why don't you fill us in?
It's probably one of it's just another one of those cyclical aspects, because the Gulf Stream varies in its flow. It will slow down the sinking. The sinking will speed up. So there's always going to be variations with that. That is also possibly tied into the Milankovitch cycles. We have the the changes in the tilt of the axis, the ellipticalness of the orbit, precession of the equinoxes and the solstices. That all affects incoming solar radiation, heat distribution on the planet, etc. So that's one of those cyclical aspects. But again, when you do the analyses, you have to remove such signals. You have to account for those signals when you do such analyses, and that's typically usually taken care of.
All right. I have Billy Joe's Mo. Hi, Billy Joe. Freshwater entering from Greenland shuts down at the solidation of the Gulf Stream, the motor that runs it. I guess it's not a question, but is it a accurate assessment?
That's usually a driving mechanism, is that what's called introducing a freshwater lens into the North Atlantic that will help slow down thermohaline formation. But there's another one, and I'm in the process of editing the video, where studies are now looking at the increasing freshwater content within the Arctic Ocean and what happens to that freshwater content. Does it stay within the Arctic Ocean, or does it also get flushed out the Fram Strait, so that now you introduce even more freshwater content, more of a freshwater lens into the North Atlantic with all that? So that is another, one of those cases, pick your poison. Where do you want the fresh water, in the Arctic Ocean or in the North Atlantic?
All right, let's see. How about we go with Jim? Jim did his climate change protest in Gettysburg, Pennsylvania today, as he does every Friday, and you can find him on Facebook. Jim and his lovely wife was with him today, Tanya, and they will be visiting here in a couple weeks, which is really exciting. So Jim's question, and I lost it. Okay. What is the total, what is the total system failure, system-wide, of AMOC, GS, and Southern Ovulation? Did I read?
Perhaps southern oscillation.
Yeah, unless he's just, there's a lot of things mixing in. I mean, people aren't fertile, men. Frogs can't have babies. All right. Try to
Well, a
figure it
total
out.
shutdown
Yeah.
would be no vertical sinking, and the Gulf Stream stops flowing. That would be a total shutdown.
Okay.
As I said, the data and the data we use is isotopic fractionation. We can look at O18, C13, and 15. We can look at these fractionation and ascertain when, for example, when when there were ice ages or glacial. We're still technically in an ice age, but when there were ice sheets that had expanded and retreated, we can tell when the thermohaline flow was running or not. And we do so by looking at the isotopic fractionation. I did a lengthy video on that very topic. But
that's good.
So to answer the question, a total shutdown would be no vertical sinking, no horizontal flow coming out of the Gulf of Mexico. That's what
wow, that's like. Scary shit. All right, the next one is for Jennifer. Will the methane fracture the limestones?
That's a good point, Jim, actually. And possibly, I mean, it's coming out and the limestone has gotten really hot and just all this methane coming out and even methane deposits and stores. They're talking about even methane kind of lakes could be coming out. And who knows, maybe it could. We'll have to keep a close eye on those limestone outcrops and see if there's any changes because we don't know. This hasn't happened before that we know of. I mean, in our human history in any case, but maybe it happened a little bit at the end of the last ice age. I don't know that, but it's a very good observation. It's a good question.
And Jim clarified, we know that.
Another thing.
Oscillation, not ovulation. Come on, in our show, there has to be something, right?
And, another thing, I'm looking at a study now where it's looking at the methane coming out of the limestone in the Laptev Sea. Now, here's another consequence of the warm water coming in through the Bering Strait because of the Beaufort gyra. The Beaufort gyra is a clockwise flow. Yeah. It deflects the water, the surface water, onto the shelf, onto the Eurasian shelf, so onto the East Siberian shelf, Laptev, Kara, and so on. So it deflects that warm water there, which is a major reason why we're seeing that's the sea ice over on that side of the basin of the Arctic Ocean melting faster. But you also bring in this warm water. That warm water is doing what? It's interacting with the substrate, and it's helping to thaw out all the clathrates and hydrates that are present down at the substrate in the ocean. So that is another contributing factor, this warm water being moved in, causing this kind of situation. And the study that I'm looking at is not just at the permafrost, but at the limestone formations.
Well, definitely let us know when you do that video, because that follows up to what we're talking about. Okay, yeah. Let's see. Another one here. Dwayne. Hi, Dwayne. Jim, would you say the precipitation that Ireland and the UK get off the Atlantic will change rapidly if the AMOC comes to a halt or a massive slowdown?
Well, you have that warm water moving up there, and it gives off its heat, so you get all the the fog that England is known for, as an example, and of course, it's going to lead to precipitation. So now if you cool down the atmosphere, because that latent heat will not be given off as likely, it's not unreasonable to expect precipitation to decrease. So most likely, yes, I would expect a decrease in precipitation, but you would have cooler temperatures for sure, because as we all know, cooler air holds less moisture. So, so that's to be expected.
If I could just comment, if I may, I know that already in England, they're getting a lot more precipitation inch-wise than they ever did before, hence the big floods that we're seeing. So would you expect that to taper off, or would the additional water vapor that's being held due to the hot temperatures offset that? I mean, there's so many factors to consider, correct?
Well, again, it's like everything else. Is what I just said is not going to happen immediately, but eventually, over the long term, down say a decade or two down the line, that would be an expected result. What you're seeing now is because the temperature and thus pressure gradient between high latitudes and mid to low latitude is decreasing. You are basically going to have a decrease in strength of winds, and you're going to lead to the meandering jet streams. So the jet streams slow down, and if the jet streams do pick up moisture, like going over the ocean, because don't forget, you're going to still have some, it's coming from low latitudes to high latitude. It's going to pick up the heat energy from low latitudes and dump it. And it's going to dump it like what we saw in Europe. But don't forget, we're seeing situations like on one side, literally on one side, it's precipitating like hell, flooding away, and on the other side, you got drought and high temperature, and that's because of what the jet stream is doing. The jet stream is just dipping down, becoming meridional as opposed to zonal. So it's just going to go from high latitude to low latitude, and low to high latitude, but at a slower rate. So if there's any moisture, it's going to travel very slowly, or sometimes just plain stall and just keep pissing away at whoever's underneath there.
That's what I felt like happened to us in July. It just kept pissing away and giving my garden a real hard time. Okay, let's segue. Hello, Heidi. Heidi has quite a question. Either one of you, because Jennifer, you might even know about this. How will this Gulf Stream change the ocean acidification and lobster fishing community here in Maine in Wabanaki territory? I graduated from high school and am concerned about our Deer Isle, Stonington, and international renowned lobster fishing community in down in East Maine. Thank you. Fishing communities, especially on the East Coast.
Well, of course, the Gulf Stream not only brings heat, but brings nutrients. So, it's one of the reasons, along with various, physiological and bathymetrical processes, why the Grand Banks, Georges Banks, are productive regions. First of all, they're a plateau, so you have upwellings of nutrients and so on and so forth. So if the Gulf Stream slows down, it's not going to bring as much nutrients along with it. So that's going to, again, it's going to affect the productivity. That to me is the main concern, because I'm not concerned. Well, I don't mean to say it that way, but there's enough ocean heat content that the planet is not going to suddenly cool down by 4C. But the slowdown of the vertical and horizontal currents will affect nutrient distribution, which will affect productivity. That is what I would be keeping an eye on for.
All right. Let us go on. Thank you, Jim. Thank you very much. Patrick, I guess the Arctic, how are we going to restore the Arctic sea ice? And of course, we know the answer, and that is with OMTech. Patrick's, Patrick did an interview with us. Patrick has an episode with Just Have a Think if you want to learn all about OMTech, and possibly it should be given a shot. Why not, right? You can go to Just Have a Think. Did you watch that, Jim? Did you see the OMTech video on Patrick's ideas? It all works with the Gulf Stream.
I have not. But,
all right, you have to. We're giving Patrick a shout out. Okay. Well, I don't know then if we can answer that one, but how are we going to restore it? Tech. All right. Let's see. Here's one. Microsoft Technical Word Support. Man, dry throat. I wonder what the atmospheric carbon levels were in that ancient historic analogy. If they were if they were 250 back then and they were 450 now, say, wouldn't that preclude an ice age just by itself?
Well, technically, we're still in an ice age. This is just an interglacial, technically. I mean, because if you look at the history of the Earth's CO2 levels and temperatures over Earth's history, we're actually coming out of an ice house Earth, or sort of still in an ice house Earth. Compare that to like 53 million years ago, you had the PETM, where the Paleoeocene thermal max, temperatures were 18 C above pre-industrial level temperature. And the CO2 levels was like, like well over 1,000 parts per million. So technically, we're in an interglacial, but we're warming things up. That some of the models along with the exponentiation indicates that by 2100, we'll be more than halfway towards the PETM levels, about 7 to 9 C. But again, like everything else, it's the rate of change. It's the rate, the Earth's temperature went from 18 C to, pre-industrial level over the course of 53 million years. And we're now jacking halfway up to the PETM levels in 200 years. So, it's the rate of change is just incredible what we are doing to the planet. But to your question, 450 versus 250, 450 is going to pretty much preclude any growth of glacial sheets for the near future. Let's put it that way.
Hey, I've got one here. I want to add this one. Hi, Rick. Small. Restore the Arctic. Drop the AGGI back down to 280 ppm or lower, which means destroy the fossil fuel economy, society, and culture. There we go. That's how you do it. But how do you do it? We do it if we can do it by civilized degrowth and people just go, and not necessarily death, but natural selection.
Everybody would have to stop having children.
Yeah, well, that's a given.
Yep.
That's an absolute given.
Yeah.
And that's
it's not a very
happen.
popular
Absolutely.
thing. It's not a very popular thing to say.
Oh my gosh. Forget that one. They're having kids left and right. My neighbors have kids and this one has kids, and forget it. It's terrible. It's a terrible thing to say. Oh, there's your kitty. See, now my cat's trying to get in and I have paws coming in under the door, but I won't get it. I won't get up because there's too many of them. I don't want anybody coming in. All right, let's see here. Rick, thank you for that comment. Okay.
The AGGI is actually a very useful index. It's the annual greenhouse gas index, and it was developed by scientists to actually give a value. And the value is, and the base reference is 1990. So if you look at and I'm doing a video on it, but if you look at the calculation, you may see a value of 1.27. What that means is that when you look at a square meter of the ground, 27% more heat energy per that square meter than it was based on 1990 levels. So it's I think it's an extremely useful index, and and it helps the layperson understand better, get a handle on how much heat energy that has been introduced into the system.
All right, awesome. All right, now we can get to Rich Diana. How much has the Gulf Stream slowed down? And can they quantify it? And Patrick, are you in the audience? Because Patrick could probably answer this one. This is Patrick's area of expertise.
Can they quantify it? Sure, they are quantifying it. I don't have the numbers off the top of my head, but there is the slowdown has been measured. So yes, they are quantifying it.
Okay. Any permafrost questions? We should have some. Let me see. I have to turn on the other side. Well, hey, how about a comment from my buddy Rick, because I follow his channel on permaculture, and he is definitely teaching me about a different way to think about agriculture. And he said that's what ruined the planet. Oh, where is it? That's what ruined the planet. Agriculture is the reason for growing civilization. Civilization today is on fossil fuel steroids, and here we are. Yeah, there you go, Rick. I mean, couldn't say it any better than that. Yeah, definitely. All right, well, let's get to any questions. There's only a few. How about this one? John D. Question. Jim, you're popular tonight. Nobody wants to talk about permafrost. Everybody wants to talk about the AMOC. With Jim, with so many tipping points and inertia is net zero on this side, or the other side of zero anthropogenic emissions. So many tipping points and inertia is net zero on this side or the other side of zero anthropogenic emissions.
I'm not quite sure. I mean, inertia is not. There's a lot of thermal inertia in the system already, and the mistake people make is that they're thinking of the atmosphere. Okay. They're thinking of the feedback from, say the thawing permafrost, or we have limestone splitting open, releasing methane, and so on. And of course, as we all know, methane is a more potent greenhouse gas, not as short-lived, but it still oxidizes into CO2, so the effects are still going to be felt. But the real thermal inertia is what I've been talking about, all that heat energy in the ocean. That's your thermal inertia. That is what's going to diffuse into the atmosphere and keep warming things up, I hate to say, even with a complete shutdown in AMOC. I think there's enough thermal inertia in the system that the planet will continue to warm by several degrees C, at least.
Thank you. I'm going to read Dee Dee's comment. It's about the quality of life. Too many people means too many people living in poverty, crowded with no quality, plus too many human beings are destroying non-human animals and their environment. Thank you, Dee Dee. Yeah. Well, listen, guys, we have been an hour and 18 minutes, and I know this because my back is telling me, and I know, Jim, your back was bothering you. We're the back, except for Jennifer, who is absolutely fine. She's got a good back. I am. You are.
This cat is clawing me. Gosh.
We're the fubs.
Go away.
Sandy and I are the fubs.
Yeah, we are. We're the well, I just overdo it.
We're the members of the fubs.
Okay. All right. Well, I'm going to ask Jennifer to do the closing honors, and I'm just going to say thank you. I'm tired. It's been a good show, though. I have absorbed a lot of information, and I have to say, as the layperson here, I did learn from this, and I now learned how to decipher some of the wheat from the chaff in these articles, how they're interpreting the data from the research. So that was helpful. Thank you both for that.
Yeah. Well, we're living in a time of abrupt and catastrophic change and abrupt weather events, and it's all being driven from heat, plain and simple. Now, whether it's methane, thermogenic methane coming out of rocks, or biologic methane coming out of permafrost from organisms, or the AMOC slowing down, or any number of catastrophic things that are happening right now. We're seeing many different things turning from carbon source into carbon sinks into carbon source. So we live in an amazing time, and just keep watching the news and join us back here again next week.
Yeah. Well, actually not next week. I'm on vacation. I'm actually going to be gone. Yeah.
Okay.
But thank you, everyone. Thank you, Jim. Jen, I love you. Everybody out there, all of you, thank you so much for being with us, and thank you for being our members of Buy Me a Coffee. We will see you. I will put up the schedule because I'm going to be gone from the 10th to 16th. So it's a family reunion, hence the haircut. to look a little
Mom
conformed.
will love it.
Yeah, Mom will love it. Mom will love it. All right, guys. Peace out. Love you so much.
Love you guys.
We do.
I was gonna say live long.